Today I am going to talk about data communications in computer network models. For example, OSI is one of the models of computer network, or let's say TCP/IP is another model of computer network design. So in OSI model, we examine the physical layer. All the issues are examined which are related to the data communications. What we are talking about is that any computer model, for example, we have two models, OSI model and TCP/IP model, and all these two models we have number of layers. In OSI models we have 7 layers. Physical layer is the lowest layer model. So in physical layer, whatever issue we examine, it is related to data communications. In data communications, we examine lower level details of the computer network. Just for example, when you write a program in high level language, you basically examine the logical issues. You basically examine the upper layer details. For example, applications layer protocol. We don't examine what is happening at the media and whatever happens at the signal level and so on. So the point is that in physical layer we examine the lower level details, and data communications deals with these lower level details. So I was giving you one analogy of computer programming language. So when you write a program in high level language, you are not concerned with the lower level details. You are not concerned with the computer architecture of a machine or computer organizations of a machine. But when you write a program in machine language or assembly language program, machine language, then you have to understand thoroughly about the architecture of the machine, about the organization of the machine, how many registers you have, what is the size of registers we have, the size of memory and so on. For example, word length of the machine. So this means that you have to be thorough with the lower level functioning of a machine. Same thing happens with the physical layer. So if you are designing a physical layer, or if you are examining the physical layer related issues, you are basically considering the lower level details, type of signal we are going to do, the type of multiplexing which we are going to, the characteristics of the physical media which you are going to use for computer network and so on. So briefly what we are going to talk about is like this one. So first I will talk about data communications technology. First I will talk about what is a data communications. First we will give you 2-3 definition of a data communication. There is a difference between data communications and computer network. Today we are going to talk about only data communications related issues. What is a data communications? Then we will define what is terminology related to data communications. Then we are going to talk about what we call them data transmission signals, what type of signals we use in the computer network or computer as such. You know that basically we work with the digital signals, we work with the analog signals. Within the computer we work with the digital signal, but when the signal has to be transmitted on the telephone lines, it has to be converted into the analog. So we have to understand the characteristics of the digital signals, we have to understand the characteristics of the analog signals. Then we will talk about that data transmissions mode, whether you can transmit both ways, whether you can transmit in only one way. Then we talk about whether you can transmit, how we can transmit, or so we'll talk about various transmissions techniques. For example, serial transmissions, whether you can transmit bit by bit or whether you are transmitting character by character. Then we'll talk about data transmissions techniques. We have 3-4 techniques. One is called circuit switching techniques, which is used in wide area network. We have a packet switching network. This is also used in the wide area network. So we'll talk about all these issues in quite detail, and all the issues are related to data communication. This is a part of your second trimester and the first trimester where we have a networking related course now. So let's first examine now what is a data communications now. Now data communication is basically, the definition goes like this. It is the exchange of data in the forms of zeros and ones when you are working at the applications layer. For example, when you scan the surf the net, you are not considering about zeros and ones, how data is being transmitted, or when you are sending email, you are not basically concerned. But when we are sending the data, when we are at the data at the physical layer, we are concerned with the zeros and ones. Let's examine the definition once again. It is the exchange of data in the forms of zeros and ones between two devices via some form of communications media, such as wired cable, wired media, just like a coaxial cable, fiber optics, or it could be a wireless media, it could be a satellite channel, and so on. So all types of media, you have to understand the characteristics of all these media, you have to understand at the physical layer. Data communication is considered local if the communicating devices are in the same building. For example, local area network, all the communicating devices, all the computers are in the same building, and is considered remote if the devices are further apart. So basically what we are talking about here is that when we refer to data communications, we are talking about the data communication takes place between two devices. Both the devices has to be connected directly, or it had to be connected through a communications network. Actually, if you connect two machines, data transmissions can take place, but we never do like this. Let's suppose that we have thousands of machines, all these machines cannot be connected directly, otherwise the cost will be very much high, and it will be basically this is not an effective type of system. For example, all the telephone network of the world, you can't connect them directly, so they have to be connected through basically certain communications network or telecommunications network. For example, we have a telephone exchange and so on. So the point is like this. Right now, the two things you can derive from it. The data communications takes place between two devices which are directly connected, or which are connected through basically some communications network. So we'll talk about, for example, local area network is one communications network, or wide area network is another communications network. Metropolitan area network is another type of networks. So data communication can take place within the same building, data communication can take place within the city, or data communication can take place within two different countries or two different cities and so on. So this is what, so basically at data communications we deal with at how the signal is being transmitted between the two devices. Let's examine once again. Now see another, let's try to further analyze what exactly we understand by data communications now. So basically, when we say for data communications to occur between the two devices, the communicating devices, the senders and the receiver, two devices must have. If one computer A is sending data to computer B, the computer A will be the receiver, sender, and computer B will be the receiver. So all the devices must be part of communication system made of the combination of hardware and software. So when we say that when I want to connect two systems, between the two systems you must have a communications network which will comprise of different type of hardware and different type of software. So this is basically some one or two the basic understanding of data communications now. So right now let me summarize very quickly what exactly we have discussed. So the data communication is basically transfer of data from one machine to another machine, such that the sender and receiver both interpret the data correctly. That is very much important, and that is why you understand different type of protocols now. So the basic purpose of the protocol is that data interpretations between the sender and the receiver must be fully understood. If you are sending the data which is not being received properly by the receiver, that most of the data will go waste. So all the two parties which is sending and receiving must follow the same protocol. For example, in computer, let's say take example of the internet. Now all the machines which are part of the internet, they are following the same protocol, what we call them TCP/IP. So TCP/IP, so the sender has to run the TCP/IP and the receiver has to run the TCP/IP. If they are running the different type of protocol, again there will be a problem. So all the protocols must be designed around the TCP/IP or around the internet protocol. So the last is that sender and receiver must interpret the data correctly. It means that both of the parties, both of the machines must be running the same protocol. But right now at the physical layer we basically dealing with some other issues now. We are running the protocol or the understanding of the protocol coming somewhere from the data link layer onwards. But at the physical layer we have to understand only in terms of the lower level details. We have to understand in terms of the signals, but again they follow certain type of protocols. For example, when you try to connect, when the print, like for example, your machine is connected to the printer, your machine has connected to the mouse and so on, they all are basically follow certain type of protocol, that whatever I click from the mouse, it must be appropriate, must be understood by the CPU or must be understood by the device, other devices and so on. So this is called data communications. Now let's examine now that you have broadly understood that what are the two important component of a data communication system or a computer network system. One is the sender and the second one is the receiver. Both could be a machine. So basically sender is one machine and the receiver could be another machine. But in between something else is there. Let's try to examine those things. What are other components which will comprise as a part of the computer network model, or what we call them data communication system. And let's try to identify what are those components. One is, you know, what is the source machine through which you are sending the data. Then you must have a transmitter, then the transmitter system, then you have a receiver, and then you have a destination. So let's try to understand what exactly, how to understand now. So source is the machine through which you are sending your email, or you are basically browsing the internet and so on. So this source is one machine. The transmitter is, let's try to understand, which I will try to explain a little bit in detail, that in computer we work with the digital signal, but the digital signal, we cannot transmit the digital signal the same form the way we work with the computer inside. It has to be transmitted, it has to be converted into certain format, certain form, so the signal can be transmitted over the telephone lines. So it is job of the transmitter to which will convert the digital signal into the analog signal from one side, from the sender side. Another side again, it must convert from analog signal to the digital signal. So the basic job of the transmitter is to convert the digital signal on which computer is working. So all your data, whatever you write, whether you write a ABCD, whether you write a 1, 2, 3, 4, all the data are basically converted into the digital signals. All data are converted into digital signal. So computer works only with a digital signal, which is represented by only two types of voltage, 0 or the 5 and so on. But telephone lines, data is always transmitted into the analog form. So it is job of the transmitter which will convert the digital signal into the analog form. Now then, what is the device? Let's try to find out, identify the device which converts the digital signal into the analog signal. So we have a modem. So modem is one device which converts the digital signal into analog signal. It could be the external models, but now most of the trend today is that your motherboard also contains the modem card. So it is fitted into the motherboard itself, or you can attach with external modem now. So this is a modem which is working as a transmitter now. Now the third one is what we call them transmitter system. Now here is basically what exactly is the point I was trying to explain you in the beginning, that I can connect two machines directly. I can connect two machines directly, simply what I will call them point-to-point type of network. But suppose that I have 10,000, I have thousands of machines in my system in our organization. Can we connect each machine directly to another machine? Then the cost, permutations and combination will be very much. So the cost will be very high. It's not cost effective at all. So what we do is, so just like we connect all the telephones of the world in point-to-point way, they all have to be connected through certain exchange, switching exchange, and this way data can be transferred or voice can be transferred. Same thing happens here, that all machines are connected through certain system, what we'll call them transmitter system, or let's say the word which we call them the what we'll call them communications network. And we have a local area network, we have a wide area network and so on, and then it can be further connected with the receiver. So transmitter system could be certain network through which computer is directly connected with it. So this is the another component of a computer network model. Then the receiver. Now receiver will be another side, again you must have a modem. right? So for example, I am trying to send certain data which is connected through telephone lines. It has to be converted by my transmitter, that is a modem, right? And then another side you must have a modem which will further translate back into the digital form. So this is called a receiver. So receiver and the transmitter both are modems in this case, and destination is the what we call them again destinations machine. So these are the key components of the data communications model. So we are not talking about any specific model, it's a generic model, right? So again, you might have different names of a transmitter system. You might have a different names of a receiver, but broadly we talk about computer. Broadly these are the 5 components which goes into data communications model. Let's talk about few important terminology which are related with the data communications. All these should be examined in the physical layer of computer network. Now what is it basically? Now we will not go into detail, but simply identify various threads through which you have to learn further. Now first is what we call them channel. Now channel refers to the 3 basic terminology you must be aware of it. One is called bandwidth. Let's try to understand, because there is some confusions that people always get confused between baud rate and the bit rate and so on. So the channel means that, for example, I am trying to suppose that I have connected my 2 machines with coaxial cable. So coaxial cable works as a channel. For example, in most of the local area network where Ethernet, what we call them, which runs a protocol called CSMA/CD protocol they run. Now they all have and most of the local area network system, the coaxial cable works just like a channel. In fact, you all must have a cable at home, or your cable is also connected with the coaxial cables, whose bandwidth is what we'll call them 500 megahertz. Anyway, let's talk about. So channel is the media through which data is being transmitted. It could be coaxial cable, it could be fiber optics, it could be wireless. Today we are talking about mobile computing. So the 2 machines should not be directly connected. While moving, you can send email. While moving, you can access the remote databases. You can send your email, get the email, and do most of the computing through the internet. So in this case, you don't have all these 2 machines should be connected. So channel could be wireline channel, coaxial cable, fiber optics, 2-state pair, or it could be wireless channels, or it could be satellite. You can send your data through satellite. So this could be, so you have to understand various characteristics of these channels now. In what situation you have to use what type of channel and so on, and what is its cost effectiveness. The second important thing is called baud rate. Now, so each channel must be identified by or characterized by one of its important characteristics is what we call them baud rate. So we'll talk about the baud rate, what is the baud rate, and what we have at the bandwidth. So let's try to examine now each one in. So the point right now at this stage, the baud rate is not same as the bit rate, which we say now. Bit rate means how many bits per second you are basically transmitting. The system can transmit, but baud rate is something different. Bandwidth is again something different. Let's try to examine all basic things now. So what is channel now? Although we have identified what is the channel, like for example, satellite is one channel. Let's try to examine what is the channel now. The portion of the communications media allocated to the senders and receiver for conveying informations between them. Where do you use a channel? So you have a computer, then your computer is connected with a transmitter, then transmitter must be connected with one of these channels, and then again your receiver must be connected with this channel. So this is called, so basically channel is sitting between the transmitter and the receiver, or between the 2 modems of 2 different machines. So this is called channel. Now what is the baud rate? That is very much important. You must understand the difference between the baud rate and the bit rate. The definition is like this: the signaling rate of the line means channel, which is the number of transitions, voltage or frequency changes that are made per second. How many signals are changing per cycle or per second? If that is the unit, then that is called baud rate. Baud rate could be the same as the bit rate if each signal is carrying 1 bit of data. Let's try to understand that basically in computers we have a digital signals now, and then we have a analog signals now. So basically what we are talking about is how many times a signal is changing its frequency, or what we call them voltage, frequency range or the voltage in per second of time, and that is called a baud rate, right? If each signal is carrying one bit of data, then we say the bit rate and the baud rate is same. If the signal is carrying more than one bit, then we say that the baud rate, then we say that the bit rate is more than the baud rate. For example, sometimes we say that particular, like let's say we have a telephone lines, and the one of the characteristics is called baud rate. So if we say the 300 baud rate, it means 300 bits per second is being carried by this channel. So it means that in this case bit rate and baud rate both are same, because each signal element is carrying one bit of data, which we'll try to explain a little bit later on. But right now the point is, when we say bit rate, how many bits per second, but when we say baud rate, means how many signal elements we have per second. If each signal element is carrying one bit of data, then both are same. But if each signal element is carrying more than one bit, then we say that then the channel, then bit rate is higher than the baud rate. If each signal is carrying 2 bits of data, we say the bit rate is twice the baud rate. If each signal is carrying 3 bits of data, we say that the bit rate is thrice the baud rate. So that is the important characteristics you have to understand. So if you are trying to examine the various characteristics of the channel, one of the important one is the baud rate. So now let's try to talk about the bandwidth. Now what is the bandwidth? You have understood what is the channel, you have understood what is the baud rate, relationship between the baud rate and the bit rate, and when the bit rate is more than the baud rate, then let's try to talk about the bandwidth. But just to start our discussions, you must be aware of that the coaxial cable which carries the television signal at your home is basically what we call them, the bandwidth of the coaxial cable is called 500 megahertz. Now take example of what is happening like this. Now same cable carries the signal from many TV broadcasters. They are carrying the signal from G, they are carrying the signal from our own program, they are carrying the signal from this one. So what is called, this is called multiplexing. For carrying each color transmissions, they require at least 6 to 8 megahertz. Now same time they are carrying the signal from different broadcaster, and in between there is some distance now, and this is called multiplexing. Now the point is like this, right now we are not talking about multiplexing. What we are talking about at this stage is that the bandwidth of a machine is basically is referred to as a what we call, and that is called electrical characteristics. You can't change the bandwidth of any channel now. Means suppose that if I have a 500 megahertz bandwidth of a coaxial cable, and if each color TV transmissions requires 8 megahertz, you divide 500 megahertz by 8, it means so many color transmissions, color TV transmissions can take place on the same coaxial cable at the same time. So now let's try to talk about, so this is called bandwidth. Bandwidth is basically electrical characteristics. So when we examine the channel capacity, one of the important characteristics you have to understand that what is the bandwidth of this channel now. Now let's try to give now appropriate definition of a bandwidth. The amount of data that can be transmitted in a fixed amount of time, right? So depends upon what we are carrying, whether we are carrying the digital signal, whether we are carrying the analog signals. So right now it's basically independent of what type of signals you are carrying. Simply we are writing amount of data that can be transmitted in a fixed amount of time, amount how many bits you are transmitting. For digital devices, the bandwidth is usually expressed in bits per second. How many bits per second you can transmit the data. For analog signal, the bandwidth is expressed in cycle per second, that we call hertz. Even your clock of the machine, for example, I have a Pentium machine, so it is the bandwidth might be the clock, how many times the signal is changing, that is called a bandwidth. So there might be 500 megahertz or let's say 200 megahertz, means 200 million signal elements are occurring per second. right? So we say that I have a 500 megahertz Pentium processor and someone has got, let's say, 250 megahertz Pentium processor. It means that the 500 megahertz Pentium processor is twice faster. Of course, not that way is calculated, but roughly logically it is twice faster than a Pentium processor which is supporting you 250 megahertz. So means what exactly we are talking about, that if the channel capacity is more, if the bandwidth of any channel is more, then definitely more data rates can be achieved, right? So again, it also happens sometimes in computer network, we have discussed that with same bandwidth, means if you have a more bandwidth, more data rate can achieve, but keeping the same bandwidth, you can achieve more data rates by different encoding techniques. You can provide one signal to carry 2 bits. You can also provide by using different encoding techniques that each signal will be carrying 3 bits or 4 bits. It means that with same bandwidth, we have increased data rate twice or thrice. So that issues you have to examine very much. So right now, what we are talking about is that if we are carrying the digital signal, then bandwidth can be referred to as a bits per second. But if I am carrying analog signals, then bandwidth is basically hertz. Right now, broadly we are talking about the hertz. So we can have a megahertz, that could be a bandwidth. So the coaxial cable bandwidth is 500 megahertz, means 500 signal element is changing per second.